Yes, last time we were doing this transforms. I hope getting all of you the result for this solution. Please respond. Have you done the problem? Because last time we were doing the calculations on sine, cosine transform, how it is changing and giving you the answer in terms of Z. Have you done or not?
Yes, ma'am.
Got it? No answer for this. Alpha is here cos of k pi by 2. So alpha is pi by 2. Okay. So first of all, you have to expand the term and then simplify cos of a plus b expansion. So already we have done, and we are using cos alpha k.
Yes. Ma'am, is it alpha or A? What do we can call it? Alpha or A? Because
Alpha is
simply,
pi by 2.
okay. No, I have solved it like that only, but I was confused about the nomenclature, alpha or A. That's it. It should be alpha, na?
It is alpha. It is alpha. The notation which I have used, no, that is alpha. It's not
Okay.
A.
Madam, excuse me, madam. Can you please share video of this earlier lecture, because I was not present that time and I couldn't
Yes.
get
Actually, it
what
is
was
taking
done.
time to upload. Every time I'm
Yeah.
doing that video, but it is taking time to upload it even on YouTube also, because I'm taking it on that and then sharing with you. But anyway,
Okay.
I'll keep it in mind, and that second lecture is also there, so I'll just upload it. Okay.
Yes. Okay, ma'am. That is why I couldn't solve it, because I was not present for the lecture.
Okay.
Okay.
See, this is all formally based complete topic, that Z transform. So how much the answer you know for a particular sequence, accordingly you have to just use it in the example and solve it. That's it. So for that you have to just correlate what is that A represent, what is that K represent in the example, and accordingly you have to just put that formula there and simplify. That's it. Okay. So again, I need not have to solve. I think all of you are getting, majority of you are getting the solution for this one. Alpha is equal to pi by 2. You have to use and expand cosine function, cos of a plus b formula, in which cos pi by 4 term you will get and sine pi by 4 term you will get, which is 1 upon root 2. Okay. So now I am just showing you the properties of the Z transform on which we are going to solve the example. So just to see, and then on my pad, I'll be just doing the.
Good afternoon, everyone. So today's meeting's agenda is that we all have appointed for the BTech students for internship and mentorship. The same students have been allotted.
Sanket sir,
So
will you mute
the
yourself?
important thing has to do is first check whether your students is going for internship. You have to update it in the same sheet whether they are going for internship or not. And also you have to check whether those students have paid the fees or not. We have also circulated a mail regarding this, where we have attached a file. In that particular file,
excuse me, ma'am.
Ma'am,
Can you just share us the final answer of this so that we can cross check what we have done is right or wrong?
Yes, I'll be doing just before that. Let me share this one.
Okay, ma'am.
See, f of k, you are taking it with cosine function k pi by 2 plus pi by 4. So expand this by cos of a plus b formula. So cos of k pi by 2 into cos pi by 4 minus sine k pi by 2 into sine pi by 4. Correct? And therefore, we are getting Now you have to just put the values for cos pi by 4 and sin pi by 4 because those are fixed values, fixed constants, which you have to use 1 upon root 2 cos of k pi by 2. And similarly, sin pi by 4 is 1 by root 2 into sin k pi by 2. Okay. And here you have to use the formula for Z transform of the cosine function alpha k, where alpha is pi by 2. Again, whose mic is on? Nikhil sir, Nikhil Survade Patil. Please mute yourself. Just tell me, your another lecture is going on?
No, ma'am.
Madam, sound is coming from Sharda Sanjay Patil.
Sharda Patil. Yes, Sharda Patil also. Sharda Patil, Sharda madam.
Project managers role, the part it is a matrix, balance matrix.
Ma'am, from your end, you can ask them to unmute. Mute, sorry. Ma'am, please ask them to mute.
No, I'm asking, but they're not doing. So I'm just removing the candidates now. So using Z transform of cos alpha k, alpha is equal to pi by 2. The result is Z into bracket Z minus cos alpha upon Z square minus 2Z cos alpha plus 1. Okay, this is your standard result of the cos alpha k Z transform. So here in place of alpha, you have to just put pi by 2. So you will be getting the answer from here, that is 1 upon root 2. Then Z into bracket Z minus cos pi by 2 upon Z square minus 2Z cos pi by 2 plus 1 and minus 1 by root 2 second term. Sine of alpha k result we have to use. Sine of alpha k is result is Z transform sine alpha k is what? Z sine alpha upon Z square minus 2Z cos alpha plus 1. Correct? So here we will get minus 1 by root 2 into Z sine pi by 2 upon Z square minus 2Z cos pi by 2 plus 1. Okay, this is the result which we are using it here. And cos pi by 2 is, what is cos pi by 2?
0.
0. So Z minus 0 upon denominator also Z square plus 1 only we are getting. And what is sin pi by 2?
1.
1. So this is Z upon Z square plus 1. So final answer will be Z square upon 1 by root 2. You can keep it total common Z square upon Z square plus 1 minus Z upon Z square plus 1. That's it. If you want, you can take common LCM Z square plus 1 and make the expression here. Z into, so Z square upon Z square plus 1 minus Z upon Z square plus 1 is the final answer for the Z transform. This is it.
They don't care if I understand.
Okay. Have you got, madam, the answer? I think Dhanashri madam was asking, no?
Sincere.
Yes, ma'am.
Huh.
It's clear.
Yes.
We are on the same page.
Yes, yes. So now I'll be sharing that properties part, which is already shared in the classroom. I think all of you have joined now that new classroom, which I had sent you the link. I think I have seen some 25 students are there. People are there on this. Angad sir, please mute yourself. Angad sir, please mute yourself.
एकदम नॉर्मल तेवढं जर मी पिलं तर कुठेतरी पडली असेल रे मी रस्त्यावर मी पण फुल पॉट झालं
Oh.
Okay, so we'll continue with the next part where the properties we have to discuss. Yes. All of you can see now the screen.
Yes, ma'am.
Yeah. So please, already the notes already I have shared in the classroom. Everything is there with all the topics. Notes are there available. But please see immediately on the day where the topic is taught. Okay, so that it will be easy for you to understand the things. So in this case, in the properties, actually there are many properties for the Z transform where we are taking it, we are using frequently few of them. So first is a linearity property where you are getting directly the addition with two transformed answers together, and that can be considered as a linearity property. So first property A into f of k plus b into f of k, if it is added, and if the Z transform is taken for that, then it is a separate two transform result. So A outside, which is a constant, Z transform f of k plus B outside, Z transform g of k. Similarly, second is a change of scale property. Scale means this is a fk is transforming to fz. Okay, so that is actually your scale. But now when f of k is multiplied with a raised to k, then your scale will be changed with z by a. So your answer is just you are going to make it f of z by a. Whenever the sequence is multiplied with a raised to k. Okay, so that is the transformed answer. You have to just remember z transform a raised to k. It's not inverse, it is z only. This is wrong. Okay. Z transform a raised to k f of k is f of z by a. So if the transform f of k is for cos alpha k, it is there. And if it is multiplied with 2 raised to k, then in the answer, you will be just replacing z with z by 2. That's it for the cos alpha k transform. I will show you on the pad how this is coming with the help of these properties. Similarly, like here, cos alpha, Z transform 3 raised to k cos 2k, it is done. So cos 2k ka transform we can find out with the help of standard formula of the cos alpha k result. Okay, this is your standard formula for cos alpha k, where alpha is equal to 2. Now it is multiplied with 3 raised to k. So A answer is 3. That means in place of Z, it is replaced by Z by 3, Z by 3 here, denominator also Z by 3, 2 times Z by 3. Rest of the part is the same. Understood? So that's the change of scale property. Now similarly, this is third one, which is a Z transform f of k is f of z. Then if that f of k is multiplied with e raised to minus ak this term, then your answer f of e raised to a into z. So in the answer of f of k transformed result, you have to just multiply z with e raised to a. For example, this is done. E raised to minus 3k cos of 5k. What is that? This is giving you cos 5k का answer is just a transformed answer. This is z cos alpha का result use करके. And then if it is multiplied with e raised to minus 3k, then that z will be replaced with e raised to 3 into z. Only that much you have to just change it in the expression, and similarly in the region of convergence. So this is the transformed expression which we have to use it. So region of convergence is this one, e raised to z modulus is greater than 1. Okay. Similarly, multiplication by k. So z transform of f of k is fz every time. This is a consideration. Then if that f of k is multiplied with only k, okay, this is the only term, k term is used here, this one. Which is giving you minus z d by dz of fz result. So you have to differentiate fz term, multiply with minus of z. And in general, if it is multiplied with k raised to m, okay, so k square, k cube, k raised to 4 into f of k, then your transformed answer is fz answer has to be multiplied with this particular term, that is minus z d by dz raised to n into f of z. Okay, that is the result. If you are simultaneously noting down in your notebook or somewhere else, it will be easy for you to understand. Otherwise, go to the standard notes which are shared with you in the classroom. So refer that and see one by one property. With the help of that, we are solving the examples based on this. Okay. Are you with me?
Yes, ma'am.
Yes, ma'am.
Yes.
And therefore, using this property, we are having this example k into 5 raised to k. What is 5 raised to k transform? That is given as z upon z minus 5. Okay, using a raised to k answer, standard sequence. And when it is multiplied with k, only k raised to 1. That means you have to differentiate this z upon z minus 5 with respect to z and multiply with minus z. Gives you the answer is 5z upon z minus 5 raised to 2. Standard form. Okay. So this is the property. Most of the time we are using this multiplication property. Now this is also z transform of k, suppose it is asked. In this case, it can be considered as z of 1 or z of uk. Okay, the standard sequence uk is multiplied with 1 or k is multiplied with uk. So uk ka transform a unit step function, that is z upon z minus 1. And therefore multiplication property will give you minus z d by dz of z upon z minus 1. This particular result is to be used for the transform of k only. Likewise, division by k. So any sequence is divided by k is giving you minus integral z raised to minus 1 fz dz, means fz upon z. This means that it is fz upon z into dz. Okay, and in the integral. So integration you have to carry out with respect to z, that's it. Like for example, sine 3k upon k is given. Okay, or k greater than 0. Then we know the sine 3k transform by standard sine alpha k form is z sine 3 upon z square minus 2z cos 3 plus 1. So when it is divided by k, this is, then you have to take the integration of this fz term along with z raised to minus 1. Z raised to minus 1 means 1 upon z. That gets cancelled with this z and we'll get the answer sine 3, which is constant. And this is integral 1 upon z square minus 2z cos 3 plus 1. So integration is to be carried out with the standard form. That means denominator is adjusted and done it with this form that we will do it. Okay, I'll show you on the pad. This is the calculation for the integration, which is to be, the answer is calculated with the help of this cot inverse z minus cos 3 upon sine 3. Then this is some shifting property which is used. F of k plus n is equal to z raised to n f of z. Z f of k minus n is z raised to minus n f of z. Shifting matlab that k is shifted to k plus n and k is shifted to k minus n. In some term before and some term after that k. So that gives you the answer as z raised to n into this thing. Then for one-sided Z transform, one-sided matlab either k less than 0 or k greater than or equal to 0. So f of k plus 1 is giving you this result summation. Then f of k minus 1 is giving you another result for k less than 0. Okay. So these are the two transforms which are one-sided Z transform which are considered. Then for causal sequence is only k greater than or equal to 0. We will be getting number C. Okay. So anyway, at present you can just note down. We will be using these results in the calculation for the difference equation. So that we are doing. And this is one more important seventh one. Yes.
Ma'am,
Huh?
can you go a bit slow?
Yes, I'm going to show you on the pad. Only thing, this is just overlook on this one. This part already I have shared. So I'm just showing you, this is the property which we will be using in the example. Okay.
Okay, okay.
So this is shifting property, then convolution. So convolution between the two function is this particular operation, which we call it as the star operation. This one is also important because convolution takes place in Z transform, in Laplace transform, in Fourier transform. For everywhere, the functions, two functions, three functions, a convolution means what? You have to just get one function and shifted second function, that combination. So here f and g are the two sequences. Then the convolution of these two is nothing but the summation of one function multiplied by shifted second function, that is g of k minus m, and m is ranging from minus infinity to plus infinity. So what happens to its Z transform? The answer is nothing but you have to just get the product of their transformed answer, that is fz multiplied by gz. That is the calculation. So fz into gz is the convolution of the two functions Z transform. Like here one example is shown for the verification. When f1k is k, f2k is equal to k, and k is greater than or equal to 0. So dono functions k hai, and you want the convolution between this f1 and f2. Okay, so f1 and f2 ka convolution matlab this term you are going to select it. I'll show you on the pad. Okay, at present this is just a simplification which is done here. Similarly, this is a another example, cos of 5k plus 7, it is quoted with the help of this thing. And lastly, the examples which are given as the exercise where you can try the expressions with the help of the standard properties. Okay, I'll go to and connect my pad and let me see how we can go ahead with this. Using the properties of the Z transform. And on the classroom, I have shared the formulae for the Z transforms also, list of formulae. You could see, no, the results. Please tell me, can you see the material which is shared on the classroom?
Yes, ma'am.
Yes, ma'am.
See in that Z transform का ये जो PDF में दिखा रही हूँ, same thing I have shared, in which the properties and the examples, everything is listed over there. Okay, so with the help of the properties and the standard sequences, we are going to solve the examples using this is Z transform.
Hello, ma'am. Hello.
Hmm?
Ma'am, Sanket Tirpude sir is there in waiting room. Can you please allow him?
Yes, yes.
Sweet. Already I have enabled.
Yes, yes. Thank you, ma'am.
Very good. Very good. So we have explained the meaning of that aspect ratio, distinctness, how it is measured, how it is calculated in a proper way.
Mic is on again.
This thing I was missing from all the students who has presented before you. It was a good session. Hoping that the others who are listening to the session, they came to know how it is measured, how it is calculated. So, okay. So next,
Sagar
Nimesh.
sir, please mute yourself. Yes, thank you.
Excuse me, ma'am.
Yes.
Actually, I need to leave from my institute and I will rejoin after 4:30 because I will be in commute.
4:30, what you have?
I will, may I rejoin at 4:30 because I have to go out. I mean, our institute is closing now.
Okay.
That's right.
Pradnya
Yeah, thank
madam,
you,
no?
ma'am. Yes, ma'am. Thank
Yes,
you.
no problem. Yes, so let me some examples based on this. So examples based on the properties, we will be just seeing one or two expressions, and then further we are going to define the inverse Z transform also. Okay. So here we will take first of all find Z transform of e raised to minus ak find the Z transform of the e raised to minus 3k into cos of 4k with k greater than or equal to 0. Find the Z transform based on the property e raised to minus 3k cos of 4k, k greater than or equal to 0. So what is the property tells us? Since using the property for e raised to minus 3k, if you can refer to that classroom notes, you can just open that and tell me how we can use the property for e raised to minus ak into cos into f of k property. Okay, so using Z transform of e raised to minus ak into f of k result. What is that? The answer, which is equal to f of capital F of Hmm? Can you refer and tell me what is this?
F of e raised to a into
Hmm?
z.
Yes, e raised to a multiplied by z, where capital F of z is the z transform of f of k. That should be known. So here, z transform of f of k. F of k is, or f of k is equal to cos of 4k. F of k is cos of 4k, and e raised to minus ak is e raised to minus 3k. Is e raised to minus 3k. Therefore, a is equal to 3. That is understood. And therefore, now we are interested in z transform cos of 4k. Who will tell me this answer? Cos alpha k का आंसर यूज करना है. What is cos 4k answer? Hmm?
Z minus z into z minus
Hmm?
cos of 4 divided by z square minus 2z cos 4 plus 1.
Very good. So this is the answer for cos of alpha k expression. Alpha is 4 here. That's the cosine transform. Okay. So cos transform, z transform obtaining. This is your FZ. This is your FZ. And therefore, when z is when cos alpha cos of 4k is multiplied with e raised to minus ak into cos of 4k, that means in the fz function you have to replace z with e raised to z. That's it. So replace z with e raised to a into z. I'll call this as 1. In 1, and therefore z transform e raised to minus ak multiplied by cos of 4k is equal to e raised to az. Wherever there is z, you replace it by e raised to az, where a is your 3. So e raised to 3z into z is e raised to 3 into z minus cos 4 upon e raised to a e raised to 3z cos square minus 2 into e raised to 3z cos 4 plus 1. That's it. That is the transformed answer for e raised to minus ak. Are you following?
Yes, sir.
Good. So this is how we are using the property e raised to minus ak wala form. If you want to use that multiplication property, suppose for example, if I want to use this multiplication property for, say, it is asked, find the z transform of k square into e raised to minus 2k. K is equal to 0. Find the transform of k square into e raised to minus 2k. So what we will do in this case, we have to use the property for using the property z transform of k raised to n into f of k result. Multiplication by k property. K raised to n into f of k multiplication is minus z into d by dz raised to n actually into fz. This is what we are having the result for this multiplication. So here now k square is given. Okay, therefore z transform of k square e raised to minus 2k means f of k is equal to e raised to minus 2k, and k square is the multiplication. K raised to n is k square, which implies n is equal to 2. That you can understand. And therefore z now you should know what is the transformed answer for e raised to minus 2k. Therefore, Z transform e raised to minus 2k, first of all, you have to calculate. That is your FZ. Okay. Who will tell me what is e raised to minus 2k transform? We have done this calculation for e raised to ak. If you remember. Using Z transform e raised to minus ak transform k greater than or equal to 0, which is, you can write down directly this result. It is in the standard formula which I have already sent. In that it is there, Z into e raised to minus a upon Z minus e raised to minus a ka square. This is, sorry, e raised to minus a. The transformed answer with k multiplication. You can take it. It's equal to Z transform e raised to minus ak, which is 1 minus, e raised to minus a, 1 minus e raised to minus a into Z raised to minus 1 raised to power minus 1. This is actually the answer for the transform of e raised to minus ak. Okay, 1 upon 1 minus e raised to minus a into Z raised to minus 1. So we will use this. So this is the answer for FZ. Okay, so when e raised to minus 2k is there, we will take this answer as 1 minus e raised to minus 2 into Z raised to minus 1 plus power minus 1. That means FZ is equal to 1 upon 1 minus e raised to minus 2 into Z raised to minus 1. Okay, so this is your FZ, capital FZ. So what you have to do is just differentiate that term, and because it is multiplied with k square, therefore Z transform k square into e raised to minus 2k means minus z into d by dz ka square, n is 2 of fz. That means you will put minus z d by dz square of this 1 upon 1 minus e raised to minus 2 z raised to minus 1. Is it okay? Are you following?
Yes, ma'am.
तो differentiate करना है इसको 1 upon 1 minus e raised to minus a z means e raised to minus 2 z raised to minus 1 को differentiate करना है. So how you will differentiate that? Using the property x raised to n. What is the differentiation of x raised to n? What is the differentiation of x raised to n? x raised to n का differentiation क्या होता है? What is d by dx? d by dx of x raised to n.
N into x raised to n minus 1.
Yes, n into x raised to n minus 1. So ये property we will use it here. So this is like your x raised to minus 1. So while doing now we have to do 2 times differentiation. So first differentiation I can write down as, now here it is d by dz, only that is the change. So which will be minus 1, 1 minus e raised to minus 2, z raised to minus 1 raised to minus 2, correct? And x raised to n minus 1 is this, multiplied by, now this is your term, z raised to minus 1 multiplied with e raised to minus 2. So that term would be multiplied with the given expression as a differentiation. So e minus 2 into z raised to So e raised to minus 2 will remain constant, and 1 upon z differentiation. 1 upon z differentiation is minus 1 upon z square, correct? Which is minus, actually this is minus 1 upon z square.
That's good.
So that is to be written as a multiplication. We have first differentiation. One more differentiation we have to carry out. It is minus of minus, you can keep it as a plus, and 1 minus e raised to minus 2 into z raised to minus 1 plus raised to minus 2 multiplied by e raised to minus 2 z raised to minus 2. This term will be coming. Okay, so total answer is minus z d by dz of, this can be written as, and take it, can be written as z into just by taking the LCM upon denominator z square we are getting, and this term also will come in the numerator. So total answer I am writing, this is z into e raised to minus 2 upon z minus e raised to minus 2 the whole square. After simplifying this, simplifying matlab take the expression in the denominators and taking LCM, simplify this one. So z into e raised to minus 2 upon z minus e raised to minus 2 ka square. This will be the expression remaining. Okay. Now while doing another differentiation, we have to do again the differentiation of this term. So therefore, this is minus z and d by dz of this term. Now d by dz of this particular expression, which is z upon z minus e raised to, now e raised to minus 2 is anyway constant, that you can keep it outside. Okay, and you can do only the differentiation for z term, z upon z minus e raised to minus 2 ka square. And how you will proceed for differentiation? Can anybody tell me how you will proceed for this differentiation? How you will do this one? By which procedure differentiation can be done?
Division rule.
Division rule, very good. So just by division rule, u by v rule for differentiation. That means z minus e raised to minus 2 square into numerator ka differentiation. Numerator is z, whose differentiation is 1 with respect to z, minus z as it is denominator ka differentiation. So that is 2 times z minus e raised to minus 2 into differentiation of this z. This term and multiplied by differentiation of z is 1. So everything divided by z minus e raised to minus 2 raised to 4 for denominator square. मला हे सगळं उचलून नाही लागते कनेक्शन. Getting this one? That simplification. What is that simplification in turn? It is coming out. I'll give you the answer for that simplification. Is z into e raised to minus 2 multiplied by e raised to minus 2 z upon z minus e raised to minus 2 raised to power 3, because one of the term is getting cancelled with the numerator term. So we'll be getting this with modulus of z greater than mod of e raised to minus 2. That is the region of conversion. So this is the answer for the double differentiation. So when it is multiplied with k square, then we are getting it 2 times differentiation. एक बार एक differentiation for this fz term, and once again it is differentiated. 2 differentiations are carried out, and we will be getting this answer as the fz term. Okay. थोड़ा complicated sum है because this is given with the denominator term when you are getting, that will give you the differentiation. Complicated sum. Let us see the expression of this. One simpler form I will take it with k into this expression. So for example, find the Z transform k into 5 raised to k for k greater than equal to 0. K into 5 raised to k for k greater than equal to 0. So can anybody tell me what is the 5 raised to k transform? F of k is 5 raised to k. Okay, for k greater than equal to 0. So what is fz? What is fz?
Z upon Z minus 5.
Yes, very good. So z upon z minus 5. That's the transform of 5 raised to k. Okay, and region of convergence you know for that modulus of z greater than mod 5. So this fz may you have to take multiplication with k. Therefore, z transform of k into f of k is equal to minus z into d by dz of fz. That is minus z into d by dz of this is z upon z minus 5. Can you do this division differentiation and tell me the answer? I'll give you 1 minute. Let's try.
Madam, 5Z upon Z minus 5 bracket square.
Yes, yes. Yes, that is coming out as 5z upon z minus 5 the whole square. All of you are getting? Final answer is coming out as 5z upon z minus 5 whole square. No difficulty, no? This differentiation. So we'll take one more example on the division form. Next example, you can take it. Find Z transform is the division. So sign of, say, suppose sign of k upon k. Find Z transform sin 2k upon k. K greater than or equal to 0. Find the Z transform of the division property you have to use. So first of what is the division property? Using Z transform f of k upon k. That k is greater than or equal to 0 is nothing but but integral over z. Z raised to minus 1 into fz dz. That is the calculation. Okay. So here f of k is sine 2k. So find out what is the answer for fz. Therefore, capital Fz is equal to, what is this? What is capital Fz answer? Who will tell me what is the transform of sine 2k? See your, if you have written it in your notes, what is sine alpha k transform? Yes, written or not? What is sine 2k transform?
Yes. Z sine 2 divided by z square minus 2z
cos 2 plus
cos
1.
2 plus 1.
Correct. Cos 2 plus 1. It's very correct. So z answer we got it. And therefore z transform of sine 2k upon k is nothing but the integral over z. Fz, actually z raised to minus 1, fz means fz upon z. That means integral of, this is z to infinity actually. This is because k is greater than or equal to 0. For that we will be using the result for the integral. See, z to infinity. Upper limit is infinity. So 1 upon z into bracket z sine 2 upon z square minus 2z cos 2 plus 1. So this z and z is getting cancelled. Sine 2 is anyway constant, which you can keep it outside the integral, and we'll get dz upon z square minus 2z cos z cos 2, sorry, plus 1, which is to be simplified. Okay. Therefore, this is sine 2 integral z to infinity dz upon whenever denominator is containing some quadratic term like this, adjust it like 2 terms square expression, because that has the standard formula in the integration. So here what I will do, z square minus 2z cos 2, and that 1 can be replaced with cos square alpha plus sine square alpha. This cos square 2 plus sine square 2. Can I write like that? This one can be replaced with this. Correct or not? Becomes a sine 2 integral. Now, what I will do, I'll take this z square 2z cos minus 2z cos 2 plus cos square 2 together, this one. And I will write it as one perfect square. So how do you write that perfect square? Z square minus 2z cos 2 plus cos square 2 can be written as a perfect square of what? Z cos 2 whole square, correct. And remaining only one term is this sine square 2. Okay, and here now therefore same, this is standard integration. X upon x square plus a square integration is 1 upon a tan inverse of x by e. This is a standard result of integration. Okay, so in this case, x is this. This is your x. This term will be your x, and this is your a. This is a square. So we'll have therefore sine 2 as it is. And answer is 1 upon a, means 1 upon sine 2. into tan inverse of x means z minus cos 2 upon sine 2 in the limits z to infinity. The limits z to infinity. So this is getting cancelled sine 2. Now if you put z equal to infinity upper limit, infinity से कुछ subtract करो या add करो, it is remaining infinity only. So upper limit answer is tan inverse infinity. Lower limit answer के लिए negative sign and z is the replacement for z only. So that is same. Z minus cos 2 upon sine 2. What is tan inverse infinity? Tan inverse infinity is for which angle tangent ratio is giving answer infinity? That is for 90 degrees. Okay, so tan 90 is equal to infinity. That means tan inverse infinity is pi by 2 minus tan inverse of second term as it is z minus cos 2 upon sine 2. And that can be further written as cot inverse of z minus cos 2 upon sine 2. That's it. So this will be the result for the transform of f of k upon k. So we have started from the standard result z to infinity, z raised to minus 1 f z, and calculated with this particular form. Any doubt regarding this? Yes? Following one. So one problem will be for the convolution. See, for one or two functions or directly you can have this result. Find, next example, find Z transform of xk, where xk is equal to, capital X you can write, xk is equal to 1 upon 1 raised to k dot 1 upon 2 raised to k star, you can make it, okay? Star operation. Star 1 upon 3 raised to k. So 3 sequences are there and their convolution is to be calculated. Okay. So this means it is a convolution of 3 sequence. Convolution of 3 sequences. So let us take one sequence as a of k is equal to 1 upon 1 raised to k. B of k is equal to 1 upon 2 raised to k. And C of k is equal to 1 upon 3 raised to k. And whose separate answer you know for the transformation. So 1 upon 1 raised to k means 1 by 1 raised to k, a raised to k transform. So using the transformed answer for a raised to k and k greater than or equal to 0. What is this answer? A raised to k answer, if anybody remembers? Or if it is there in front of you in the notebook, what is a raised to k transform?
f of z by a.
It is z upon z minus 1 for mod z greater than 1. A raised to k transform already we have done in the beginning for the first lecture. Standard sequence. So the answer is z upon z minus 1. Okay. So use this result for all these 3 sequences and get fz answer. Therefore, z transform of 1 upon 1 raised to k will give you, this is z minus a, sorry, mod z greater than mod a. So 1 upon 1 raised to k means z upon z minus 1. Okay, so you can call this as AZ answer, capital AZ, transformed answer. Similarly, z transform 1 upon 2 raised to k means z transform 1 upon 2 whole raised to k, which will be, what is this answer? BZ answer. What do you get? In place of a, you will put 1 by 2. So this is z upon z minus 1 by 2. And if you simplify, that becomes 2z upon 2z minus 1. Am I right? I'm just putting a answer as 1 by 2. So this is, you can call this as bz. And z transform of 1 upon 3 raised to k means z transform of 1 by 3 bracket raised to k. It's one and the same. That is z upon z minus 1 by 3. That is 3z upon 3z minus 1 for mod z greater than mod 1 by 3. It's the region of convergence. And what our convolution property is telling, since convolution of two functions f of k star g of k is nothing but their product transformed answer. So fz into gz, this is the transformed answer. So here therefore z transform of ak star with bk star with ck. Three sequences are there whose answer is az multiplied by bz multiplied by cz. Yes or no? That is giving you the answer as z upon z minus 1 into 2z upon 2z minus 1 into 3z upon 3z minus 1. That's it. For modulus of z greater than half, greater than 1 by 3, greater than 1. So all together it is mod z greater than half. Together we can write down. Yes, are you following or not?
Yes, ma'am.
Doing, no? So please do it along with me and it will be there in the notebook and you can refer it while solving the examples based on that. So this is one example where the convolution property is used. So likewise, multiplication by k, division by k, then convolution, then multiplication with e raised to minus ak, and etc. The terms will be used for finding out the transform answer for this z expression, z transform of the given expression. Okay, so one I think I forgot to do, that is a change of scale property. That is also one important one. You can take this one. Find z transform of 4 raised to k multiplied by sine of k plus 3, k greater than or equal to 0. Okay. So we have one change of scale property using change of scale property, that is z transform of a raised to k into f of k is equal to f of z by e, where f of z is a z transform of f of k. Okay, so here f of k is your sine of 2k plus 3. So whose transform is to be identified? Sine of 2k plus 3. Sine of 2k plus 3 means what? You have to take the expansion. Sine 2k into cos 3 plus cos 2k into sine 3. Already we have done sine of a plus b. So this is, we are writing it in terms of that. Cos 3, sin 3 are constant and therefore z transform of sine 2k plus 3 means what we'll get? Cos 3 constant as it is, z transform of sine 2k plus sine 3 as it is, z transform cos 2. and this is nothing but cos 3. Sine 2k transform is z sine 2 upon z square minus 2z cos 2 plus 1. This already so many times we have done, so you can remember with the help of that. And plus sine 3 multiplied by cos 2k ka transform z into z minus cos 2 upon z square minus 2z cos 2 plus 1. Refer to the standard results of cos alpha k and sin alpha k, standard sequence. So this is the answer for fz you are getting. Okay, so this is the value for fz, and therefore you are multiplying this with a raised to k. Therefore, 4 raised to k into this thing. Transform 4 raised to k multiplied by sine of 2k plus 3 equal to, therefore, what you are going to change is in z, you will be changing z by a. What is a? A is 4, correct? So wherever there is z in fz term, you will be replacing that z by 4. So replace z with z by 4 in expression 1. Okay, and therefore z transform 4 raised to k sine of 2k plus 3 is nothing but cos 3 into z by 4 sine 2 upon z by 4 square minus 2z by 4 cos 2 plus 1 first bracket plus sine 3 into z by 4 multiplied by z by 4 minus cos 2 upon z by 4 square minus 2 into z by 4 cos 2 plus 1. That's it. That becomes the transformed answer. 4 raised to k into sine of 2k plus 3. Okay. Got it? Got the result for this one? Yes, are you with me and following or not? Or any difficulty? Because calculations, unless you do yourself, you are not going to understand. This is what the mathematics which you have learned in UG level. So I'm of course not expecting that immediately fast calculations you can do, but wherever that is required, I'm writing everywhere the reason, which property, which formula, that way we are using and calculating. Yes or no? Yes. So there are now, these are the properties along with the standard sequence. So please see the formulae given in the classroom. Z transform K, 2-3 pages I have given you as the formula. Of course, everything you need not have to mug up, that is not expected. But the standard sequence, and in the initial lecture I told you how to get the transformed answer, that is by summation expression. So if something if you don't remember, then you can put it in the summations and simplify that geometric series and get the answer for FZ. That is actually required. But few examples or few standard sequence, few standard properties are to be remembered, then only we can simplify the examples. Okay, so on your own you write down on one page whatever the formula given. Please don't see the already typed expressions. Do it and write it separately on your own, so that it will be a some understanding also will be there, plus memory also will increase with
मला
the
पाठवलंय.
Now, with the help of this transformed and their properties, standard sequences and the properties of the Z transform, we will be doing the exact reverse process of it. Reverse process means finding out the answer for the inverse Z transform. And our ultimate aim is to find out the solution of the difference equation in the Z transform. So for that, we should know both the things, how to take the Z transform, how to take the inverse Z transform. Okay. So in the inverse calculation, we will be seeing one particular method, that is partial fraction method for finding out the inverse Z transform. Other method I'll just show you as one example, because one is the power series and one more is the inverse inversion integral method. So anyway, which are not very useful. The second method, which is partial fraction method, is more useful and frequently used to solve the examples. So in the next part, we can just write down inverse Z transform. Inverse Z transforms. In your classroom notes, this is a separate document attached, inverse Z transform. So that refer it, and which will help you to solve the examples based on that. Now what happens? We are taking the Z transform of f of k sequence, which is resulting the function in fz, capital F of z. So now we will be doing exactly a reverse way. What is a reverse way? So which implies which implies z inverse of this fz should give you the original sequence, that is f of k. आ रहा है समझ में? This differentiation and integration are the reverse processes of each other. Whatever you do differentiation, that answer, if you integrate, you will get the original function. It's like the same thing. So inverse Z transforms are playing the exact reverse role of this Z transformation. And we are finding out the answer for this inverse Z transforms with the help of partial fraction method. So using partial fraction method, we'll find out the inverse Z transform. Find inverse Z transform. Okay. Now partial fraction, many of you have studied in your 11th, 12th school level also. So maybe remembering, but anyway, I'll be giving you the note for that and how we can use this when solving the inverse calculations. What do you understand by partial fraction? Yes, anybody can tell me what is a partial fraction?
Divided into parts, madam?
Yes, divided into parts, but that's a fraction. So you are given fraction, you are doing it part-wise fraction. Okay, part-wise fraction means you have to make the parts of that fraction. So it is not a simple way how to just do just multiplication. If it is there, then you can take it separately and do it. But there is a procedure for this fraction. Okay, so when the denominator's degree is greater than numerator, then we use the partial fraction. So what is that partial fraction? So I'll give you here this thing. So for example, this is some numerator is there. I'm writing an R for numerator divided by, you have the denominator term as, say, now as we are doing in terms of z, so I'll take it in that form only. So az plus b and cz plus d are the factors available in the denominator. Both are linear factors, as you know. Linear matlab degree 1. So So AZ plus B is a degree 1 and CZ plus D is also degree 1 factor. Okay. So now denominator is having 2 factors, and with one factor we have to split that fraction. So I can write down this as A upon AZ plus B plus B upon CZ plus D, where capital A and capital B are the unknowns to be evaluated. Okay, where this capital A and B are to be determined. Okay, now how you will determine? So your given fraction, left side wala fraction, is same as the right hand side fraction. Matlab left hand side ka numerator should be same as the right hand side numerator. So left hand side numerator is equal to the right hand side numerator. And what is right hand side numerator? That is capital A multiplied by CZ plus D plus capital B into AZ plus B. Am I right? Right or wrong? This is denominators. You are taking it as a LCM. So LCM is a product. So first term may CZ plus D is not there. So we are multiplying with that A. Second term AZ plus B is not there. So we are multiplying with this B. I hope you are understanding this one. Are you
Yes,
with
madam.
me? Yes.
Yes,
So
madam.
this is your fraction form. So how to get now capital A and B answers? For that, we will put two values for this Z. So put two values for Z and find A and B, because you will be getting two equations in A and B, capital A and B, and they will give you the answer for this AB. So that you will be putting it here, and you will be getting the answer as a splitting fraction or part-wise fraction. And getting the inverse transform, this is easy. For inverse transform, this will be easy. And like that. Okay. So this is one calculation for the denominator terms AZ plus B plus CZ plus D. Like that, we will be getting this. Similarly, I'll call this as a first note. If the denominator is this one, the second one you can take if the denominator contains some repeated factors. Denominator contains some repeated factors.
There is some background noise.
Repeated factors means some numerator upon, I'll take AZ plus B factor repeated and CZ plus D. Repeated means twice degree. What is the total degree of the denominator? What is the total degree of the denominator? 2. 3. So there will be 3 unknowns. A, B, C. So A upon AZ plus B. Now see the way I am writing the fraction form. B upon AZ plus B the whole square, and plus C upon CZ plus D, the third factor. And therefore put 3 values for Z and determine ABC by equating the left hand side numerator to the right hand side numerator. Left hand side numerator is equal to right hand side numerator. That means capital A into bracket AZ plus B into CZ plus D plus B into bracket CZ plus D plus C into bracket AZ plus B the whole square. From that you will be getting answers for ABC by putting these 3 values of Z in this expression. Okay. So just to remember, this is a note for the partial fraction which we will be using in the inverse calculation. So I'll just tell you how inverse is taken and you please see the formulae connected to the inverse. Okay, how this inverse is happening? As I said, this is Z transform of f of k. If you know the answer for fz, usko sirf ulta karna hai. Okay, for example, so standard inverse is standard inverse Z transform. That means, so suppose for example, I know Z transform of a raised to k or k greater than or equal to 0. What is the answer? Z upon Z minus a for mod Z greater than mod a. This is the region of common. This is standard sequence. Therefore, I'll take its inverse. Inverse transform of what? Z upon Z minus a, which is equivalent to what you will get? What you will write?
A raised to k.
A raised to k. And this is sequence for k greater than or equal to 0. So likewise, you can just get the expansion. One more, I'll just show you. Z transform cos of alpha k, you know, for k greater than or equal to 0, which is z into z minus cos alpha upon z square minus 2z cos alpha plus 1. So if I take, therefore, Z transform, Z inverse of right hand side part, Z into Z minus cos alpha upon Z square minus 2Z cos alpha plus 1, then I will get the answer as cos alpha k for k greater than or equal to 0. Are you following? This way, the standard answers you have to just get it with the help of that inverse formula. Most of the time, this is required. Because we are taking it into the partial fraction form, so our denominator is तरह का होगा. It's like a linear factor. This is your linear factor. Z minus A, Z minus B, like that. And that answer you have to just get it in terms of A raised to K, 2 raised to K, 3 raised to K, and like that. So today's part के लिए there is a homework that you have to just see the inverse formulae, inverse Z transform formulae which are uploaded in the classroom. Okay, the newly joined classroom that already are there. So please see and write down in your notebook on your own.
Ma'am, but
Writing. So that
excuse me, ma'am.
yes. Mhm.
But ma'am, when we click on those formulas link that you have provided now, we get to the same class that is not working. We are unable to open
You are unable to join.
No, I have joined the classroom also, but the link that you have provided na, to see the formulas for Z transform and inverse Z transform, when we click on that link, na, we get redirected to the classroom page itself.
No, I'm not getting what it is saying.
And when we click on the link that you have provided na, for the formulas of Z transform and inverse Z transform, we get redirected to the classroom page.
Okay, but you cannot see them, the formulae and all.
No, ma'am. No, ma'am.
Is it?
We are able to see. We can see, madam.
That is what, because I have checked that I can see no.
Actually, the link has been shared with us, and when we click on the link, we can see those printouts, Xerox sheets of those formulae.
No, ma'am, I am unable to get those PDF. Can you WhatsApp on group?
Yes,
Ma'am, you must be there on old new classroom.
Okay, in the WhatsApp group I will send it.
Okay, ma'am.
And all of you join that new classroom. The previous classroom where you have joined, in that I'm not uploading anything because nothing is accessible for you.
Yes.
So likewise, you just write down on your own also the inverse formula and get the result in terms of f of k sequence. And in the next lecture, we will see how this partial fraction method can be applied to find out the inverses for them. Okay, so that will be the last part of this Z transform. On Saturday, I'll be taking. Saturday is comfortable, no? All of you, 3:45. Or any doubt? Okay, somebody is asking for the syllabus. I'll share that also. Yes, all of you can join, no? 3:45 on Saturday, or any difficulty?
Yes, ma'am.
Yes, ma'am, we can.
Yes, ma'am. Yes, ma'am.
No.
Yes, so no problem. Then Saturday I'll send you the same link is there. You can join the same. This is a recurring meeting. Okay, all of you can join that time. And come with the formally understanding and getting the results. At least to do something daily. Something in daily means at least some 15-20 minutes to spare for this part. Then you can understand much better way. And assignment based on the Z transforms. Also, I will upload it in the classroom that you can see. If you want it on the WhatsApp, we can do that. In the WhatsApp also, can we create our group for mathematics only, because that group is containing all other teachers are also there, no? Other subject teachers. So instead of that, I'm thinking then if you want some study material on WhatsApp, then it's better that we will create our own group for mathematics. So I'll create that and I'll send you. Will you join?
Yes, ma'am. That will be better.
That will be better. Yes.
This is the first assignment, na, madam?
Yes, first assignment for the Z transform I will be sharing on Saturday once I cover that part.
Okay, madam.
Okay, okay. And then we will start with the Fourier transform next, the Laplace transform. Okay, so I'll conclude the lecture today. Chat box, what do you have? Yes, classroom में material जो है that is accessible to all of you, then no problem. But some of you cannot do that. Assignment के लिए I'll give you 8 days also. After that you can upload. And your exam will be, of course, subjective type. Coursework exam. Yes. We'll meet on Saturday at 3:45. See you. Bye-bye.
Yes, ma'am. Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thank you, ma'am.